Welcome to MedAura, the channel. Today's topic is the difference between the sympathetic and parasympathetic nervous systems, two divisions of the autonomic nervous system that control the body's involuntary functions. Although they work on the same organs, they do so in almost opposite ways, and they're built differently at the level of the neurons themselves. Let's start with their overall role. The sympathetic nervous system is responsible for the fight or flight response. It activates the body during stress, danger, or physical exertion. The parasympathetic nervous system is responsible for the rest and digest response. It activates the body during rest, allowing it to conserve energy and carry out maintenance functions like digestion and repair. These two systems generally act in opposition, each one adjusting an organ's activity in the opposite direction from the other. Next, let's look at where these systems originate in the central nervous system. The sympathetic nervous system originates from the thoracic and lumbar regions of the spinal cord, the middle sections of the spine. For this reason, it's often called the thoracolumbar division. The parasympathetic nervous system originates from two separate areas, the brainstem and the sacral region near the base of the spine. For this reason, it's often called the craniosacral division. Now let's look at the neuron arrangement, which is one of the clearest structural differences between the two systems. Both systems use a two-neuron pathway to carry signals from the central nervous system to the target organ. The first neuron in this pathway is called the preganglionic neuron. It starts in the brain or spinal cord and travels to a cluster of nerve cells called a ganglion. The second neuron is called the postganglionic neuron. It starts in the ganglion and travels the rest of the way to the target organ. In the sympathetic system, the ganglia are located close to the spinal cord, forming a chain along its length called the sympathetic trunk. Because of this,
sympathetic preganglionic neurons are short, while the postganglionic neurons are long, since they have to travel a greater distance to reach the target organ. In the parasympathetic system, the arrangement is reversed. The ganglia are located close to or even within the target organ itself. Because of this, parasympathetic preganglionic neurons are long, while the postganglionic neurons are short. This difference in neuron length also affects how the two systems behave. Because sympathetic postganglionic fibers are long and spread out, a single sympathetic signal often activates many organs at once, producing a widespread whole-body response. Because parasympathetic ganglia sit right at the organ, its effects tend to be more localized, targeting one organ or a small area at a time. Next, let's compare the neurotransmitters each system uses. In both systems, the preganglionic neuron releases the same chemical messenger, acetylcholine, which activates the postganglionic neuron across the ganglion. The difference appears at the second connection, between the postganglionic neuron and the target organ. Sympathetic postganglionic neurons release norepinephrine at the target organ, which produces the fight or flight effects. Parasympathetic postganglionic neurons release acetylcholine at the target organ, which produces the rest and digest effects. There's one notable exception to this pattern. Sympathetic fibers that supply the sweat glands and certain blood vessels release acetylcholine instead of norepinephrine, even though they belong to the sympathetic system. There's also a key difference in the receptors that these neurotransmitters bind to at the target organ. Norepinephrine, released by sympathetic postganglionic neurons, binds to adrenergic receptors, which come in two main types, alpha receptors and beta receptors. Alpha receptors generally cause smooth muscle contraction, such as blood vessel constriction, while beta receptors generally cause smooth muscle relaxation, such as widening of the airways, along with an increase in heart rate and contraction strength. Acetylcholine, released by parasympathetic postganglionic neurons, binds to muscarinic receptors on the target organ. Acetylcholine also binds to a different type of receptor called nicotinic receptors, but these are found at the ganglia in both systems, where the preganglionic neuron connects to the postganglionic neuron. Because sympathetic and parasympathetic postganglionic neurons act through different receptor types at the organ itself, the same organ can respond in opposite ways depending on which system is signaling it. Now let's compare their effects organ by organ. On the heart, sympathetic activity increases heart rate and the force of contraction, while parasympathetic activity, carried mainly by the vagus nerve, decreases heart rate. On the lungs, sympathetic activity widens the airways, while parasympathetic activity narrows them.
On the digestive system, sympathetic activity slows digestion and reduces blood flow to the gut, while parasympathetic activity increases digestive activity and stimulates enzyme secretion. On the eyes, sympathetic activity dilates the pupils, while parasympathetic activity constricts them. On blood vessels, sympathetic activity generally causes constriction, raising blood pressure, while the parasympathetic system has little direct effect on most blood vessels. On the bladder, sympathetic activity relaxes the bladder wall to allow storage of urine, while parasympathetic activity contracts it to allow urination. Despite these opposing effects, both systems are almost always active at the same time, at different levels. This constant low-level activity is called autonomic tone, and it allows the body to make fine adjustments rather than sudden all-or-nothing switches. When a stressful situation arises, sympathetic activity rises sharply, shifting the balance toward fight or flight. When the stressor passes, parasympathetic activity rises, returning the body to a calmer, more efficient state. In summary, the sympathetic and parasympathetic systems differ in their origin points in the spinal cord, the length and location of their neurons and ganglia, the neurotransmitters they release at the target organ, and the specific effects they produce across nearly every major organ system. Together, these differences allow the autonomic nervous system to respond precisely to whatever the body needs, whether that's sudden action or steady recovery. Thank you so much for watching this video all the way through. We really appreciate your time and your support.
If you found this breakdown helpful, consider subscribing to MedAura for more videos exploring the human body, one system at a time. We'll see you in the next one.